I will present the work developed in software engineer subject to ease the comprehension of UML and the software development process through the C4 model. This work introduced an innovative practice in the subject Software Engineering 1 at the degree in Computer Science of the University of Salamanca. This course is taken in the second semester of the second year after the subject related to programming and computational skills. So, the students learn how the early stage of the life cycle of information systems are carried out. The higher level of abstraction required by software engineering makes it complex for the students and also challenging to teach. In previous year, we introduced different innovative practice in order to improve the results, the learning outcomes of the students. In particular, we focus the subject in project-based learning and other active methodologies. But there is difficulty to achieve the learning of the unified modeling language. One of the main difficulties faced is the gap that the students perceive between the systems they model and the systems they have actually coded. The model code gap threatens the understanding of UML because the students need to shift their minds from concrete code towards abstract models. So, in this context, we propose the introduction of a new approach for documenting software as a complement of UML in the subject of Software Engineering 1. In particular, we introduced C4 model. With this model, the information systems are divided in more manageable parts that can be better analyzed. Software Engineering 1 covers the definition, planning, and analysis of information systems. The whole course is driven by milestones following the software development process. In particular, there are 3 milestones: the requirements elicitation, the definition of the domain model, and the use case realization. The sessions in which UML is explained are structured following this model. Use case diagrams are presented to lay the foundation of the requirement elicitation. Class diagrams are explained at analysis level, omitting implementation level details. And sequence and communication diagrams are introduced. Students must apply the acquired knowledge to analyze and document their own information system, their final project of the subject. For this project, teachers propose a generic goal that the system must comply. Students have the freedom to design any type of system that lets users reaching the goal. One of the main issues students face is the conceptualization of the system. If the conceptualization phase is poorly carried out, it could affect the rest of the phases given the incremental nature of the project. The C4 model offers a syntax that could make the conceptualization and abstraction of a system functionality a less convoluted task. Regarding C4 model, the syntax is simple and flexible. There are 4 models to model the systems: the context, the containers, the components, and the code. Each of these levels of the C4 model is focused on a certain perspective of the system. The notation of these models is not restricted to a set of strict rules. It is more focused in dividing the system in mentioning 4 levels and in developing comprehensible diagrams. In this picture, you can see the different components that can be used to build the diagrams, the models using C4 model. The actions implemented in the software engineering course are focused on the requirements elicitation phase of the development of the final project. The students were asked to identify the main requirements and users of their final project through use case diagrams. And the simplified syntax of the C4 model is set to help them identify main actors, external system, and internal components, without thinking about how the internal components works. The two first levels of the C4 model, the system context and the container levels, were employed, letting students design their system at a high level. At the end of the semester, when the students have developed their final project, they are asked to do another C4 model of the final system. This new model should be similar to the one developed at the beginning, but with the specific components that are part of their final solution. When we implemented this approach, it was the last academic year, and the final project was focused on designing a system that completes the goal of promoting diversity in business contexts. Although the ideas fulfilled the project requirements, students had trouble documenting them with UML. So, using the C4 model, the students could combine the static nature of the system with its functionality, using the recognition of conceptual classes and use cases. In the following slides, we show the application of the C4 model of one of the final projects developed during the last academic year. In particular, in this slide, you can see the context view of a proposed inclusive hiring system using the different components of the C4 model. In this other slide, you can see the container view, in which you can get more details about the components inside the system and the connection and the relationship between these components and also the components that are outside the system. That could be the actors and the persons and other systems connected with the developed system by the students. Here you can see the connection between the C4 model and the UML approach. In this case, you can see the use cases to show how to the conceptualization of the user manager container that was described in the slide before. Detecting the relationship among containers at the first stage of the project, students can rely on these associations and the information requirements of each container to build their domain models. Finally, the third milestone is focused on the development of interaction diagrams that are based on the first stage of the final project. Finally, the third phase of the final project is represented through sequence diagrams, as the sample saw in this slide. The use of C4 model helps students with organization of functionalities at the requirements elicitation phase. Students can work with a methodology closer to business contexts that can be understood by the stakeholders. And also this methodology is also closer to the reality of how systems are being currently developed. Finally, it's important to highlight that the C4 model does not replace the UML language. In fact, the four levels of the C4 model can be represented through UML diagrams. As a future line, we will continue applying this proposal in the forthcoming years and analyzing the learning experiences and the satisfaction of the students involved in this approach.